So this one is on your problem set. And then the clarification that I need to make is this nitrogen is sp2 because when you, I guess that's also one of the clarification I need to make. It says like I said something different from your TA. Is that, is she still? Okay.
It's similar, but like the T actually says about for oxygen and it's single bonds and it's like negative charge on oxygen. It's like the T says it is sp3, but maybe I remember that if you said before it's on hybridized P.
Okay, so let's go over this together. Okay, to bring everyone on the same page, this is also I went over in today's in your discussion menu. In the discussion menu, page 26. There's two methods of counting hybridization, right? So we are on the same page with where we are. It says count electron group. Are we good with this? Okay. If your electron group is 3, is sp2. If it's 4, is sp3. Okay, right? 2 is sp. Are we good with that? Okay. When we count electron group, okay, what is electron group? It has two different things. Lone pair and bond, right? Okay, when we said lone pair, that's the clarification I made in the class today. Should not, okay, should not involve in resonance. Okay, which means she's right with you don't need to count resonance because you don't really need to draw them. But if you see this lone pair can be involved in resonance, okay, should not be counted.
So even in like a really big molecule like the one that we were given an example of, I should know that.
Yeah, you have resonance on this small portion, right?
Okay.
Yeah, so it's a this is what happened when the molecular form. Okay, when the molecular form, it's not going to. Resonance is kind of like, let's do this way. If you can lying down, you don't want to stand up, right? If you can sit down, you don't want to standing up. If you can lying down, you don't want to sit on a chair. You always want to go to its most comfortable position. It's more or less the same way as the molecular. It's not going to say, okay, I have a huge molecule. I'm going to do exactly the same thing as what you drawn. It's more or less like, oh, I'm going to find the most comfortable way I feel like.
Okay.
Are we good?
My question, sorry,
Yeah.
one little follow-up. So for this nitrogen, this still has a lone pair.
But that lone pair cannot be involved because the one next to it is sp3, right? Okay, I'll still draw on the board. So
Which one?
this one, okay, she was asking about this nitrogen. In the very bottom.
No hybridization.
So this one, this is sp3. Okay, this carbon is sp3. Okay, sp3, as we said, block electron flow, right? Block electron flow because it doesn't have this empty p orbital. Because this sp, okay, it doesn't have an empty p orbital that your electron can jump into. It blocks electron flow. So this one is 1, 2, 3, 4. So that's sp3.
Okay.
Yes.
Does that make sense?
Yeah, that makes sense. Thank you.
Okay. Okay. What was your question on delocalization then?
Well, it's mostly about involving the problem set. I believe it's question 5 or something like that. I didn't understand the concept behind delocalization.
Okay, then it's nothing with this one, right? Then I'll erase this one and I'll start a new one for you, I guess. Yeah.
It's like still I still need clarification about like if this is one oxygen atom and it has single bond connected to a larger group, but there's no it's no resonance, and which hybridization type is that?
Okay, let's say you are talking about, is that what you mean? Like oxygen here?
It's like the oxygen is just
like that's where it ends.
No, the other part just end with oxygen and this negative part on it. active charge on it.
This one.
Oh yes. Yes.
Okay, if this is sp3, then it block, right?
Yeah.
Okay, you do this way, although it's not going to be on your test, but we do this way. It's bound with 1, 2, 3, 4, where none of the electron can really involve resonance, then it's sp3. But I know it's on problem sets probably said like unhybridized
Yeah,
orbital.
so
It's okay if it's with itself. Really, it's not going to hybridize. But according to your discussion menu, it's probably going to say sp3 because it has so many electrons. The fact of this one would be the p orbitals on the oxygen is going to stay on its own, just like our model. The fact would be. But if you really write sp3, I guess one, it's not going to be on your exam. Two, if you really add sp3, I'll still count correct because it's according to your discussion menu.
So if we write one or the other,
P. If
which-
you write unhybridized P, is that also correct?
That's correct.
Okay.
Because the true fact of this oxygen is it will have another 3 loop like this. Okay, it's just like the lone pair. The true fact is just that it stays with itself. But I know according to your discussion menu, it will give you sp3, which that's why I probably won't set a oxygen one.
So it's like as you maybe mentioned in your previous office hour, it's like if one atom is connected to like less than 2 bond, it will count it as unhybridized or just like Cl.
Unhybridized. Okay.
If the atom is connected to only 1 bond, it's less than 2 bond, it will be counted as like unhybridized. Is that
So are you talking about this one? So you have a carbon, which is that something you were talking about?
she's saying that in our discussion we were given like an example of a halogen, like chlorine, for example.
Okay.
Made 1 bond and it was the same as that.
Okay.
It was the same as that.
Uh-huh.
So we were taught that it was supposed to be unhybridized P because it only has 1
1
bond.
Yeah, that's the same
Yeah.
thing. Yeah, that's the same thing as this one. Yeah. Yeah.
Excuse me.
Are we good?
Sorry.
okay?
Thank
so
you.
so that O is, I mean, the upper O with double bond is sp2, right?
Yeah, it's sp2.
Okay, thank
Yeah.
you.
Wait, so
I'm good.
wait a minute. So to recap, so this.
The fact of this would be
is-
there's a p orbital just staying here, and then it's not doing anything. But according to your discussion menu, it should be sp3, which if you write this, I won't count wrong in midterms or exam.
Okay.
Are we good? The true fact is there's just this lone pair standing there. It's not hybridized with anyone. It cannot do anything. It's just standing there, and waiting for a hydrogen to save it. Just, yeah.
So
Okay.
does that mean that it would count as unhybridized p orbital?
Yeah, so the true fact is unhybridized p, but I also know, according to your discussion menu, it's giving a different way, which will tell you sp3. But I don't want students to get confused on if like the true fact is this, but I also know the discussion menu writes this way. Are we good?
Yes.
Okay.
But can you also call it sp2 if it does resonance?
Okay, if this one is a double bond, it's sp2 for sure.
Oh, that's okay.
Okay, are we clear with this?
Yes.
Okay. Okay,